Chris and Christine, welcome to the QTS Experience. Christine, you're back on the episode. Thank you.
Looking forward to it.
We didn't scare you away last time. You'd have to really do something crazy to scare a nuclear scientist away from coming on and talking.
Yeah, we're kind of hard to scare.
Hard
to startle.
I hope so. Well, Chris, you weren't on the show last time. Why don't we start the conversation here? Introduce yourself, and what do you do?
Yeah, name's Chris Lohse. So I work for the Gateway for Accelerated Innovation in Nuclear. That's GAIN for short, because it's a lot of words to put together in one sentence. Officially the Innovation Technology Manager for GAIN, but I spent 15 years in the commercial power sector working on nuclear power plants as an engineering consultant, and joined the lab about 3 years ago. And now mainly I support the GAIN voucher program, where companies can come utilize a unique critical infrastructure and experience in national labs to help advance their nuclear technologies moving forward, whether it's an advanced reactor developer or someone in the supply chain, or even a company looking to use a nuclear energy in their portfolio somehow.
I know we're going to come back and talk about the programs specifically. Before we do that, Christine, can you remind our audience who you are and what you do?
So since he's already went through the acronyms of GAIN, I can just say GAIN. I'm the director for GAIN. We work at a national level, working across all the labs. Before joining Idaho National Lab, I spent 27 years with the existing fleet, domestically and globally. My expertise has been on maintenance of power plants. So as I think about commercialization, and this is really where Chris and I excel inside the government, is understanding what it takes to operate these plants, because that's where we've lived most of our career. And so we come in looking at the expertise and the research and the knowledge that we have in the national labs, try to export that to accelerate commercialization of these technologies.
I cannot think of a technology topic that is more talked about, really even than AI, in critical infrastructure or data center, that sort of transcends these different technology groups, because everybody needs access to power. We all have sustainability goals. We all have, we need reliable, safe, always available, affordable power in order to have an economy and connectivity. We got to have those two things. And it's one of the few things that is at least as common, if not more common, as ChatGPT or AI or whatever the phrases are out there. So I'm really excited for this conversation. And usually I just riff off the top of my head. We'll do a little bit of that. But because I'm sitting with two very smart nuclear people, I'm going to write some questions down, which I have already prepared. So let's dive into this one. Christine, when you and I mentioned, and but Chris, dive into any of these. You and I spoke before, and you mentioned that the demand for electricity and decarbonization is reshaping the energy system. How has this evolved in particular over the last 18 to 24 months? We talked or published our podcast about a year ago, a little bit more than that. But from then till now, or just in that last 24 months, how's the conversation evolving?
Well, I think the progression of AI has been the biggest change. And in terms of changing the amount of energy demand that's out there, but it's also the rate of that change that's needed. I don't think that was really expected. I think Chris and I are both a little pessimistic in terms of understanding what the peaks actually are and the performance that the data centers need, and then how that drives out into technology. The other thing that's happening is a recognition. We are starting to see problems with reliability in different parts of the grid, and understanding that we talked before about there's one thing that takes longer to build than nuclear, and that's siting and building new transmission. Yeah. And so our transmission grid is doing the best that it can, but as you add more renewables onto that system, it does become difficult. It's meant to operate at a particular frequency. When it can't achieve that frequency, it starts to become unstable. And I think the other challenge that's not talked a lot about, even with data centers, nuclear can't solve all your problems. And I say that because of the reliability that you need. Nuclear is one of the best generation sources out there with very high capacity factors in the high 80s to low 90s. But when you're talking about reliable power for 99.999, however many nines you guys want to add to that, that's a challenge for any system. The other thing that's changing...
Well, why do you, excuse me for interrupting.
Yeah.
I'll keep writing down things if I don't back up, but starting right there, why do you think that? Because we're able to get to at least 5 nines now with the mix of grid that we have. Why do you think, because I wrote down oscillation and renewables and the challenge with, intermittent energy and base load, and we're going to come and talk to that in my data center section of my notes.
Yes.
But why do you think, whatever the number of nines is, traditionally for a concurrently maintainable, it's 5 nines, so 99.999. Why do you think there's, what about that is concerning, do you think? Either one of you.
I think the thing is, because the pace of AI and the demand for power for data centers is so fast, really it's people trying to move outside the utilities at this point, right? You're seeing some of these behind the meter setups, the Amazon Talon deal, right? And then the whole what's happened with FERC and what they've done with the commission there and those rulings is everyone's saying, well, can we take the most reliable thing and figure out how to hook up next to it and run something without waiting for a grid interconnection, right? Because grid interconnection timelines are not short. They're longer, right? People have to look at where to add power to the grid. So it's more the question of if you're trying to move quickly, you're starting to question what the reliability metrics might be or what they are. Whereas if you're on the grid itself, you're still going to run, I assume, with the diesel backup generator situation or some sort of backup situation to help meet the reliability factors with the normal grid connection. But it's more of like there's rather than just like bring your big giant data center to the grid and hook up, everyone's saying, how can I move faster? How can I deploy these quicker? How can we do this 5 times and grow these things not from 100 megawatts to, now people are talking gigawatt size. And so that these are just strains on the energy system overall in terms of, we haven't, probably since we did lots of, smelting of metals and big giant fabrication, we haven't added large loads to the grid like this in quite some time.
Really, since the 60s, early 70s.
Think baby boomer time.
And we're gonna talk about. I've got a whole data center section here, which they're attracted to this idea of self-generation, microgrid, behind the meter, variety of terms, and we'll come back to that. Seems to me when
before you go there,
please.
Sorry.
No, go.
The other aspect, the reason you can get that reliability today is because of the grid that you're pulling from still has a significant amount of baseload power from fossil fuel assets. So if your sustainability goals drive clean energy, and we can't build it fast enough in the near term, right? You're going to have to choose the reliability and potentially, and I know people don't like it when I say this, running coal plants longer to get the power you need today, and using that as a pathway to help convert to nuclear eventually. Yeah. But the other part that's changing in our energy system is people recognizing the economic opportunity in supplying energy and that haven't necessarily been involved in it in a big way before. And I think the biggest challenge we have for nuclear is people that are interested in nuclear energy that don't have it in their portfolio today.
What do you mean?
So you have utilities that have many different generation sources, and maybe coal, natural gas, and renewables. They may be looking at batteries, those types of things, but they don't operate nuclear today. They may be in a state that doesn't have an operating nuclear plant. So the hurdles are higher for them to come into this. And part of that becomes, who are your partners? So who do I partner with? Because at the end of the day, a nuclear project is still a bet the company kind of endeavor.
Right. Back to your comment earlier about when a grid uses intermittent power, and intermittent could be solar, could be wind. When the renewable resource is moving, it has lots of energy, many times more than you need, and it's available to the grid. And when the wind is not blowing or the sun's not shining, it doesn't have it. And so you either have to have storage to ride through that, or you're serving a load that doesn't need it. You can just turn it off. It doesn't matter. It doesn't interfere with anything. And so base load, like my refrigerator, doesn't like that. It doesn't like to be turned off and on. It can't hold its breath. The moment it loses electricity, it stops the compressor, which stops keeping for cooling, etc. But there are other things that we can just turn off and on, and it's really not a Bitcoin machine, for example, and just turn off, turn on. They don't particularly care, at least according to them. I'm not a Bitcoin operator, but that's what I'm told. And so there are uses for power. Even in a data center, not everything in what we call the white space or the IT space. So that's where the white space is literally in a data hall where all the customers' computers are. And those systems are almost all protected by UPS infrastructure. So if we lost grid power, it doesn't matter. It's still running on the UPS for a period of time until a secondary source, either the grid comes back or a secondary source comes up. Could be diesel gens, could be some other form. A number of them are being investigated. And then once the grid is stabilized, we cut back over to the grid. But not everything in the data center is that. A lot of stuff outside of that white space is not. They don't need to be. Life safety is the stuff that keeps the IT load protected is, but the rest of it is connected to the generators or not connected to the UPS. So if they just lose power, it doesn't hurt them. It's like turning off a light bulb and turning it back on. Give it a minute or so and they're back on. And so more and more data center designs, and we'll talk about this more, are looking at what part of this data center, if it's a 1,000 megawatt data center or even a 100 megawatt data center, need to be 5 nines, the 911 system for the sheriff, what the operating rooms at the local hospital, and can we demise those within these different environments? And what of the environments don't need to be? And in the past, that was really difficult to do. We didn't have a lot of the tools to go in and get that really precise into the infrastructure. But the tools over the last 20 years have gotten so much more sophisticated. We are ourselves consumers of AI and other tools to help us manage this infrastructure. And so that's the hope anyway, or that's the idea as we develop this. But to your point about intermittent and oscillating, that's also a concern for us because we primarily are base load unless we're talking about certain types of AI, and certain types of AI are spin up. We call that training loads, and they spin down. I don't know if the IT infrastructure though that those loads serve could be as resilient if all of a sudden they're, they reach for power and it's not there in an elegant way. I don't know.
I think people are looking at this a number of different ways. I mean, I'm no data center person, but
not with that attitude.
Yeah.
You were impressing me in the beginning with all your nuclear credentials.
But I'm a mechanical engineer, so watch out. So, but I mean, with all that, right? It's everyone just looking at how they can operate their loads, what's flexible, what's not. I mean, people have talked about, even dummy loads, right? So you run AI training or whatever that, and when it stops, you just go from max load to zero. That's not very good on a grid either, right? So do you put dummy code in there just to spin processors and run ones and zeros for whatever reason you want, right? Just to shift the power down so people can adapt.
Is it possible? I'm not an expert because this is all of us are in this conversation right now. What's more likely? And so what we would do is we could have load banks that are creating big toasters that are making artificial load. Could we partner with Bitcoin mining and other things that can be spun up or spun down? And so as the load if training all of a sudden oscillates. In other words, it's not so much the power, it's that the training's not running anymore. Like it's up running for whatever the moment is, and then it stops. Well, that's as disruptive as the power source being available and not available, right? And so how do we balance this? Whereas the things that are humming along in our homes tend to just hum along on our homes with very little change other than the LED lights come on. And the grids have gotten so good. By the way, I don't know where some of the public utilities, some of my peers and friends felt like we should pick on the public utilities. These folks have so well balanced these time shifts of their loads that they have to, over the decades, as I began learning more and more of this about the art of predicting what the load was going to look like by season, by community, by time of day, by all of these things. It's rare that they do not get it right. And somehow we, I don't know, I'll probably toss that out of the podcast, but I'm just like, wait a minute, these folks have been managing this complex grid forever. And it's unprecedented times for them too, as we all try to figure it out.
Well, and understand that public utility commissioners in most of our states are appointed or elected. And they actually have a short term, right? So they come in, they get up to speed, they start doing their job, right? And then their term is over, right? So we also have to deal with the turnover in the utility commissions as well. We have to look at energy in a longer framework if we're going to get the right system out of the back end.
Yeah.
And that's all parts of it. And we have to, there was a recent study done by ISO New England where they have a lot of renewables and they're trying to figure out, like, they've actually shown where there are days there's huge gaps that can't be filled. But if you put too many renewables on the system, your thermal generation becomes uninvestable. So how do you convince somebody to build a new thermal generator or to keep one running when it's not making any revenue, right? So the system still has to make sense economically for the people that own and that want to own and operate these plants. And all of us going, in my opinion, all of us going out and solving this on our own is not going to get it done. Right. And I think, and we've talked about, and Chris and I have talked about there's going to be different solutions for different regions just because of the resources that are already installed there based on our current system. And we talked before, maybe not on the podcast, but certainly in some of our other conversations, of the herd mentality of the data center world. One goes in and you all seem to follow.
Yeah.
And then you breed like bunnies.
Right.
Yeah. Okay.
Because what attracts it for one data, the environment, sort of like, why would once somebody puts a McDonald's somewhere, or a Chick-fil-A now, I guess, McDonald's isn't in vogue now, it's Chick-fil-A, whatever it is, but they've satisfied the market conditions for a facility. And same thing for us. It's got the right mix of talent and regulation and access to power and all of the things needed for that. And if it's in the past, there's been an exit, there's been plenty for everybody. And so now when you're looking, not all data centers, but the larger campuses that have presumed large ramps, now that's also another layer of the conversation. Like, is that going to be enough for everybody, or how does it work? But it is attractive. Once we find an environment that is welcoming and attractive and has the raw elements of what we need, connectivity, et cetera, we will converge on that location.
Is there a willingness to invest in the connectivity that you need?
What do you mean?
For the amount of energy that data centers are talking about. And I think about it in the same way that we're thinking about building the energy system. You can't build all this from greenfield, right? Correct. So are you going to have to invest in new places of connectivity to achieve what you want, or are you just going to keep? I think about Northern Virginia. I don't know how much more you can pack into that small space.
Oh no, I think, Christine, everything's everything's in play. The reason why Northern Virginia is so attractive, besides being the original, really the birth of the internet in the U.S., the citizen side of the internet happening in May East in Northern Virginia and May West, right up the street from us here in Santa Clara, where we're recording this. 80% of the world's data travels through Northern Virginia. So if data lives in a data center, so that was there. But just like everything else, economics and opportunity, just like it's pushed human populations out of these big original population centers in the United States or anywhere in the world, and they pursue natural resources in other parts of the world. I was trying to explain the edge to somebody once, one of my kids, we were talking about it, and I said, well, that's, once upon a time, Cincinnati, Louisville, these places were the edge on the Ohio River or whatever, and they opened up opportunities for people to grow, inland and then from the coasts in. So is there interest in data center companies? Another way to say that is a data center operator like us is building infrastructure to house data. I mean, we're centers of data, right? So it's our customers, the cloud providers, the e-commerce providers, the social media, all the things, all the hospital data, whatever it is, all of this stuff goes into a data center. And so there will be data centers forever, large, small, intermediate size. Our cars are going to become data centers. This is going to be a data center. So there will be all of these. But when we're talking about large types of data center, which really move the grid needle, for sure they are interested in, and we are interested in all of the above, all energy sources that make sense. We're interested in, I think everybody, I don't want to speak just for QTS, I think everybody in our industry is evaluating partnering with utility for the investment. I know a number of my colleagues made it up to an INL event that you guys had just a few weeks ago. And everybody's curious whether it's, I don't think anybody's saying it's got to be nuclear or any particular energy source. Are we building out transmission, or are we doing microgrids? Are we behind the meter? Are we in front of the meter? And what's the impact of those things? Are we talking about connectivity beyond just energy connectivity? Are we talking about fiber connectivity? And how do we build the fiber connectivity? Does it have to be fiber connectivity? Can it be satellite constellations? All of it. Because the more we use, the more we want. And the more we want, the more we make. The more we make, the more we use. This is not going to, this is forever. And it is, it's easy for us to tease about the frivolous things that we do with this stuff. And we do frivolous things for sure. But we also do spectacularly powerful, tremendous, great things with this stuff. And, a third of the world's not connected to the internet. A lot of people don't remember that. And at least half of the world, including parts of the US, aren't connected to broadband. Well, if you're not connected to those things, how can you ever lift your family out of poverty? You have to have clean, safe, affordable, reliable power, and you have to be connected. Those two things in the United States and outside. And so we're interested in serving up our customers, which are these big and Fortune 2000 customers of ours, wherever they want to go. And so how do we do that when we go to reach for our fiber and it's not there? We go to reach for our energy and it's not there. Or it might be available in, the middle of the Dakotas or in the middle of the West, and it's not available in Northern Virginia to the degree or either the scale or the speed. Everybody's looking for where they can find it. I don't want to say it's a gold rush, but it certainly has everybody's attention. Does that answer your question?
A little bit. Okay. I think maybe getting Chris's perspective on the data center meeting. He was there. He's been to a couple.
Before we do that, because I for sure want to get to that, I promise we're going to do it. I have this one question that I've been thinking about, and that is, as we're kind of working up to the data center conversation, what is the role? When you think about electricity, what is its role? Or what else did I write down? The role of electricity, thermal power. How do you see them as you're thinking through this as we work up? Because I don't want to just make it about data centers, just in this larger everybody. One of the things that I hear a lot of talk about outside of data centers is reshoring. This is where Chris was sort of talking about, the manufacturing boom of the United States after World War II. We were the maker of steel in the world. We were the maker of aluminum. That was us. We not only had the resources, and you could make a living wage as a bus driver or a whatever, or a factory worker in these places. And that left for a while. And now there is a lot of talk about some, if not most of that coming back. Well, in order to do that, you got to have power. And so there's pressure from all of these things in a utility where it was decreasing the need. And all of a sudden, it's not just increasing, but by a factor of 10. So what do you think the role of thermal and electricity is?
I mean, I think taking it at a high level, I think this is all more about security, right? I mean, this is about national security. It's about energy security.
For sure, how I think about it,
right? Because if you're securing your energy needs, as you saw with Europe, and when Russia invaded Ukraine, and then they used gas as the lever tool to kind of control Europe. Well, if you can manage your own energy within your own country, you can fabricate all your own stuff within your own country. You don't have the supply chain issues. You can not be reliant on you have resiliency, things like that. I mean, that's basically where a lot of this goes, right? Is you basically have a energy mix that's secure and resilient. Then you can run your country how you need to run it. You can fabricate the goods you need to fabricate. You can manage your own supply chains. You can do all these things. And that basically just lets the country kind of run on its own. Now, there's bigger questions. Is that really the best place to be? Globalization, all those things. But I don't think we want to delve into all those.
And I think there's also a transition between national level policy and state level policy. Okay. National level policy, you can run around and you can talk about decarbonization. You can switch to a different administration and you can say, it's going to be about energy dominance and all of those types of things. Pick your verbs, right? But when you come to a state level, it has to make sense. Okay, so people in the state are elected to take care of their citizens, right? So no matter what project you're trying to do, you need to honor the heritage of that state. So when you look at states that are being encouraged to transition away from fossil, this is having a huge impact on their economy and on their future economy. And when you look at the Rust Belt, right, these are places where we manufacture most of what the rest of us use in the United States and globally, right? And now you want to switch them over. Well, switching an industrial customer is not as easy as, because they're running with natural gas and coal. And natural gas and coal can get to higher temperatures and deliver different steam quality, right? So until you match that technology, so if I had a manufacturing plant and I was making, let's say I'm making the best, most profitable set of petrochemicals ever, or chemicals. Let's just say chemicals.
I thought you were going to say gummy bears, but we'll go with chemicals.
Okay, gummy bears. I don't know that it takes a lot of energy to make a gummy bear, but
not like that. Obviously, you're making low-quality gummy bears. Petrochemicals. Keep going.
So anyway, in manufacturing that, if you were the engineer on the end of that, so I'm a chemical engineer, so I took classes in process engineering, right? If I've got a finely tuned process that delivers me a quality product reliably and delivers the profit margin that my company is comfortable with, I don't want to muck with that part. Right. I want to get an input that's the same as what I have today and do a plug and play, right? And that's, I think, the challenging thing in industrials is that's not something that you can necessarily solve generically. You've got to be working similar to the data center aspect. What are your needs? What disruptions can you handle? What is the quality that you need? Can you do it with electricity? There's steel manufacturers that are exploring doing it with electricity. Or do you need something like a forger needs something as hot as natural gas? right? Or a combined cycle plant, right? So that's where the technology matching has to happen. But you want to, when it comes down to a state level, right? So when it comes to state policy, or you've got to not just to engage with the governor's office of energy, you need to engage with the governor's office of economic development and the governor's office of commerce, right? What are their goals, right? So there's a translation that we're seeing from this national level goal of energy security and energy dominance and decarbonization and clean economy, call it whatever you want. That translation into the states is, yes, I want to do that, but it needs to make sense for us. It has to match. So that's where the work that I do that partners with what Chris does is in those states and understanding what are the companies that you have here? How do they get their energy today? What growth plans do they have, right?
And I've heard you guys speak before also, and I think great, which is talking about the impact on natural resources. If you're coming into a state, for example, what resources, whatever the energy solution is, especially if you're looking to make a change, either add something that doesn't exist now or to remove and replace something that does exist, to your point, whether it's you're trying to get to a certain temperature or you need to grow and you're constrained, you can't grow fast enough or in the right mix of the existing energy, and so you need to add to that pool. Do you guys participate regularly in that resource conversation? Do you have, for example, if somebody wants to use wind, do you have enough land? If they want to use one of the other energy sources, if you've got coal and you want to replace it with nuclear, or any of these things, how do you have that resource conversation as well?
Well, resources overall is this one of those questions on when we talk about any energy source, right? So nuclear by itself is actually one of the most resource dense, right? From an energy perspective, you have energy dense fuel, so you need to remove less material from the ground to get your actual uranium that you can actually use. The land use of nuclear is much smaller, the footprint, right, you need for generate the same amount of power as some other energy sources. So for depending on the region, right, some people are like, I have a lot of area, you can, they can look at how they want to utilize that. If you're trying to locate closer to loads and locate closer to other things, obviously having a much more dense or much more compact footprint, would obviously help yourself in terms of getting the load closer you want it and getting that power where you want it to be. So some of those conversations happen. I think, and a lot of it's really dependent on the location that the people are in. People are, some people, hey, I don't want big giant windmills in my backyard, right? Mm-hmm. So it's, it goes back and forth depending on which state you're in, what region you're talking to, and, what people are looking for, I think, in the end.
From a resource perspective, also, there's lots of different models that you can use out there. One of the pieces of work that Chris finished this past year was getting the performance characteristics of small modular reactors and large advanced reactors into the NREL annual technology baseline. This is a tool that a lot of energy offices use to look at capacity planning and running different scenarios. And if I retire this, or if I need to add this, how much is it going to cost? What does that do? How fast can I do it? Those are the types of things, the types of different models. I think the other thing we need to recognize is we've had generally excess capacity in this country for a long time. Yeah. And now we're facing shortages of capacity. And so before, you used to think, well, what are the consequences if I don't make enough for myself? Well, I'll just, unless you're ERCOT in Texas, right, you just borrow some from your friend. Well, you pay for it. You don't borrow it. You pay for it, right?
I'll just draw on it from over here.
Yeah, I'll buy some from my friend. I don't know that that's necessarily going to work in the future. And a lot of the ways, and those.
Why do you think that? Because it's not available, or because they're not going to be as willing to share?
It just may not be available. I think, so when you look at capacity planning that people do, right, you basically put in all these energy generation sources, right? You put in natural gas, you can put in coal, you can put in wind, solar, nuclear. You can add batteries in there, right? But you still need something to charge the batteries. And then you put the costs in there, and most people work towards the lowest cost, right? So you run this big giant model, and you say, well, this is the lowest cost. Well, at the bottom of most of those is buy power from the grid. That always works as long as there's power on the grid to buy. If there's no power on the grid to buy, the cost that you put in there on that last line, well, you can, it's like Texas when they had their winter storm, and people were telling the utility choice people, or whatever the right power choice groups are. I don't remember what the right term is, right? They're like, you may want to consider changing your power provider because it may get very expensive, right? And then people got the bills when they didn't change them for like $5,000 for a day's worth of power or whatever it was. And so it's that type of stuff, right? So like if you let the power markets go to do what supply and demand says, when there is nothing, it gets very expensive. So that's kind of the interesting part in resource planning, right? It's like all these things are based on, I'd say, historical factors, historical trends, right? If historical trends hold, they work. If historical trends change, they don't.
And we're saying we don't think historical trends are going to. We're uncertain looking at the next 10 years. There's
you have to go back further than what we're looking.
Okay.
You have to go back to when we had a rate of change in electricity that we're experiencing now.
Which
that we're
was
trying.
when?
Well, we didn't really have free markets then.
No, we didn't. It was
so it's even a bit different, right? Because then everything was regulated back then, right? When you had the 60s and 70s, you're adding a lot of power, a lot of load demand, right? But now you have deregulated markets, so you have a lot of places are difference between the generation source and the transmission distribution source, right? So generation's one aspect of your cost, T&D is the other, right. And so all these things are a bit different now. You let free markets control, or you don't, or you have the regulated aspect, or you don't have the regulated aspect. So it's kind of it's a different I guess makeup for almost every state.
So some of the things we see, right? Some of the things we see is, first of all, if you ask me one thing that I wish everybody would just give up, like, it's the lowest cost of electricity. It is the worst way to plan your system.
Why is that?
What levelized cost? LCOE.
Levelized cost of electricity. Sorry.
Levelized cost of electricity. Why?
Because it makes you make short-term decisions. And when you're looking at
who's they? Is it that person that you were just talking about, the official that was elected into office that will be there for a short period of time? Or is it?
Depends.
Well, LCOE, levelized cost of electricity, is just a metric to use to say, here's your all-in cost of a component, right, based on a generation cost. So this is a generation cost number. So that's like putting an electron on a wire, right. Not the cost of the wires, not the cost of the system or anything like that. So but you're taking a intermittent source like wind and solar and give it an LCOE, and people will compare that to firm sources of power like gas, coal, nuclear, right?
Would
or
hydro fall in firm?
Yeah, hydro or geothermal, right? Which can be firm sources of power, and then you compare that. Well, they're not the same. They have different makeups, right? The grid has to do different things to accommodate a variable source of power versus what it has to do to accommodate a firm source of power.
What do you mean?
Well, you need firming. So you need a firming source of power with a variable source of power to make a firm power, right? If you're truly going to create a microgrid.
A firming source of power to make a variable source of power firm. So like I run it through a...
So renewables are like
right.
Jell-O. You need to add a little more gelatin to get it as firm as you need it. You don't want...
So how do I make solar firm? So
basically you add gas to the grid.
Okay.
So, I mean, if you... one of the quotes, and I don't know if I'll get it quite right, on the Next Era earnings call from their CEO was, we're going to add solar and wind renewables for generation, and we're going to add gas for capacity. Basically, what you're going to do is you're going to add renewable generation, so you're going to add renewable energy to the grid, but then you're going to add the same amount or more in gas to match the capacity you need to meet on the grid.
And so by making it firmer, let's say I add 1,000 megawatts, a gigawatts of intermittent power, and then I would need 1,000-ish megawatts of
They'd
firm power, and when this one is running because it's got the sun or whatever, but when it starts to peak off, my firm is going to step in and make it firm.
You basically ramp the gas plant to match the generation or not be running when the renewable sources are running. That's generally what you see a lot happening in the grid.
And this is where it's important to look at system cost and life cycle of these different assets, right? One of the things that also doesn't get factored in is how long does a solar panel last? How long do turbine blades last?
Mm-hmm. What happens if they catch on fire? What's the cost to recycle?
Right. What's the waste strategy, right? I mean, we will beat the snot out of nuclear over our waste strategy and not ask one iota of a thing about what we're doing with all of these solar panels and wind turbine blades. And I'm not saying that it's necessarily a bad thing, but that's where I'm a proponent of system cost. System cost, if you mentioned before, is important to if your sustainability is important to you, then you have to have all aspects of sustainability.
It's got to be transparent, right? What's the total cost of ownership?
Right.
From the moment I put the components together to generate something, all the way up to its end of life cycle, and I need to, the tree, we planted the tree, it grew up into the forest, and now it's done, and it's receding back into the forest, and I want as much positive and as little negative as possible. And so we can only make an accurate decision if we have transparent, full information in order to do that.
And one of the things that we're seeing is, for example, some states that have seen some reliability issues have said through their, that before a utility is allowed to retire an asset, you have to show us how you're bringing the same performance in the new asset that you're bringing. So I call these laws a lot of like for like, right? In PJM, they're separating the transmission queue for renewable power.
What's PJM?
I don't know what it stands for.
We've used the acronym for too long. It's one of the regions of the grid.
We'll look it up. We'll include a link to
in the Northeast.
Okay.
Right.
Yeah,
so they're basically the grid independent system operator.
Hey, by the way, can we just clarify one thing? Because I'm presuming this. You talk about ERCOT, which just reminded me. When we talk about the grid, for many of us that don't spend a lot of time or have any expertise around the grid, how many grids are there in the United States? I have
5
heard
or 6.
There's 5 or 6. I heard there's essentially an east, more or less, essentially a west, and then ERCOT or Texas-ish, Texas and
So you
their
have Cal
boundaries.
ISO, you have the Southwest Power Pool, you have ERCOT,
MISO,
PJM,
and then you have whatever the
and then you have the
is,
Southeast. Right? Yeah, 5
So,
or so.
So Georgia Power, if Georgia Power needed more power, would it go to one of its neighbors, one of these one of the 4, because it wouldn't get it from ultimately Texas? I guess they are isolated.
ERCOT has a slight connection over towards the east, towards Louisiana, I believe.
Okay.
That's their more connection if they're interconnected.
Okay.
And I think they're...
But
it may
are
get
all
bigger.
the other grids besides that interconnected so far as you know?
In a sense.
In a sense, but we don't have enough interconnection points, which is one of the challenges. It's very difficult to push power from east to west or west to east.
So if I had a north-south freeway, Interstate 65, for example, and I have an east-west freeway, Interstate 80, for example, as they get near each other, I might have a couple feeder roads. But those feeder roads could no way, if I needed to use those to redirect traffic off of one freeway or the other, they're small little feeder roads. They can connect you or move you, but there's no way they can supply the same amount of capacity as these big freeways.
Well, and it depends. Again, we're not T&D people.
Yeah. Well, let's move on to other stuff.
Well,
then.
hang on.
Yeah,
but we've
sure.
been spending some time because it is important to understand the transmission system, because it does go to what can we build and when can we build it, which I think is really the question everybody's trying to answer. Exactly. Right? And so we have to have a little bit of a harsh reality about our transmission system, and recognizing I'm just a big proponent of making sure that we reuse everything that we can first, because I think that will make us faster. But some of those transmission connections are one way. They're not even two way, right? So that's the other thing that you have to keep in mind. That came up in a recent conversation I was having, and I was like, oh, that's only one way. Whoops.
and the only thing that's slower to build than nuclear probably is transmission.
Yeah, that's what Christine said on our first conversation. And I've referenced that a bunch of times. And when I get energy people or infrastructure people away from the microphone, without exception, they all say the same thing. Not just for energy, for fiber as well. You know, a lot of the right-of-ways are, it's the
permitting and right-of-ways are,
a lot of the right-of-ways are
already
already so full of pipelines, or we want to put solar infrastructure in there for good reason. Don't disagree with that. But the conduits are full. The paths are full. These things are full, or they're getting full. And we haven't put new fiber in the ground, really, not at scale, since the late 90s through the early 2000s, because we put in so much. People were like, and then we had the dot-com bust. And now to go do it, because we're reaching into that cabinet and fiber's getting more and more scarce, what we call long haul, so metro areas. So building fiber around San Francisco, actually, they just finished a great big project here. It's fantastic. But from San Francisco over to Denver, that is much harder to do because you're crossing not just counties, but states and all of these other things. And so to pull significant fiber from one place to the other, you were talking about, well, who pays for this? And how do I demonstrate value? It gets exponentially more complicated when I'm leaving my county or regional metropolitan area, because it may be more or less beneficial to the people I'm transitioning through than the people at the end. So all of these conversations we're trying to figure out now.
Absolutely. And I think that's where the only way we are going to solve this problem is that we all have to come to the table with our needs, and we have to collaborate. And we have to decide what are the key factors that are going to drive the way we solve the problem. And I think there are parts of this system that can be changed. I think where we can upgrade transmission, we should move on that. Going to, not a transmission and distribution, but go to the bigger wires that can carry, I think, chemical engineer, I think about a bigger pipe, right?
Yeah.
I want a bigger pipe.
Yeah.
Those are things that we can do, right? But I think we also have to be realistic about the things that we can't. And that's where in a lot of reports you'll see, because all of this, whether we like it or not, we're trying to do big projects. All of this is going to require financing. Financing does not like risky things.
You think energy generation is risky? And let me ask you, say it differently. So when you talk about, like, everybody wants a TV, but years ago, the TV that I couldn't even put it on the wall. You had to have it on a table. And if I wanted something bigger than 20 inches, like, either it came in its own cabinet, my kids can't even conceive of this, or it would bend the table in. And why we even, my Etch-a-Sketch had more clarity than these things. I don't know why we did that. And now on my wall, like, we haven't got rid of TVs. I have a television that I can lift with a finger that's an 8K definition that's 65 inches wide. My wife still yells at me because I sit way too, she's like, you cannot, I'm literally watching the exhaust coming off of the race cars or whatever I'm watching. Give me more. But it sips power. It doesn't use nearly as much power. It's the fraction of the weight. It's much more elegantly integrated into our home. Like, there's no, so who wouldn't want to invest in TVs if you're telling them, look, because human beings were attracted to that. We're attracted to moving stories and pictures and lights and whatever, right? If you took this and showed it to Sir Isaac Newton, he would think it's magic, like you're a shaman come to life. Like this is not all, there's no conception of colors like that. And so we're attracted to those things. And so you've got to have, in order to live in a modern human life, you've got to have electricity, as we said in this whole conversation. So it would seem to me that somebody would want to go in and invest in that. In the same way you were talking about transmission, and I'm not obviously transmission expert, but as I've listened to them talk about this, some of these lines with the new transmission lines that they want to do is kind of like that TV. They can run these new lines in existing infrastructure, and they're exponentially more powerful with exponentially less loss. So they're much more efficient. They're much more powerful, but you got to run them on existing transmission. So there's a safety complexity of hanging them and disruption. Who likes the new roads while they're knocking out all the roads around you so that it can be much better? You love it when it's done, but in that 5-year transition time, it's a pain in the neck. So all of this feels like, let me just jump to this because we'll stay here all day long. You guys were part of, I know, Chris, you were, Christine, I think you were referenced in it, part of this Department of Energy liftoff report. And it's, correct me if I'm wrong, but it said something like, look, we should be tripling. And I think I'm probably even being modest at that. Our nuclear energy capacity in the next 15, 20 years, we should be doing this. Why aren't we collaborating to figure out how to do that? Or here's some ideas. Do we get the sense of that report right? Or can you help us to understand what was the report about?
Yeah, so I mean, the liftoff reports, right, and the advanced nuclear liftoff one, the update, because it was an update this year. I mean, it's really just kind of out there to show the art of what's possible, right, what can be done, right? And so it's basically saying, they say, hey, we need so much firm power by, X 2050. We think 200 gigawatts of that kind of could be nucurel energy, right? 200 gigawatts. So that's basically 3 times what we have now, because, right, we have just under 100 gigawatts of current capacity in the U.S. from nuclear power plants. And going through there, basically, it runs through all the various steps. So kind of what you need to do, how you could do it, right? It talks about probably the biggest thing in there, which is newer this year. One part, well, Christine had the coal to nuclear section, which she added, and that was in there. But then you had this item about consortia, right? What are these business models you could have, right? How could it come together, right? Is the utility going to be the purchaser? Are they going to be the builder? Are they going to then be the owner operator? Is someone else going to be an investor and a utility be a builder? Or is there going to be a developer who's going to be kind of this overall builder of it, and then they'll basically get it completed and sell it to utility who will then own and operate it? Or is it like some people are out there want to, build, own, operate, just sell power through PPAs? I mean, it's all these kind of models and economic models for how you might get to a completed project. Right. Those still have to be sorted out. I think that's kind of one of our biggest factors going forward. Because I'm kind of a nerd in the way it works, I've been following all the utility conference calls the last quarter, just looking in like which analysts are asking around advanced nuclear, which analysts are asking around SMRs, what are the CEOs saying, what are they not saying, right? And a lot of the discussion comes around, well, we're participating in these projects, we're participating in some early site permit work, we're participating in some of these early things. No one's out there saying we're going to go build it tomorrow, right? And a lot of it goes to, we have balance sheet risks they're managing. So they're managing their debt, right? Because utilities are just big giant debt machines where they issue debt, they service their debt through basically recouping revenue through selling electricity, right? And they manage that balance sheet. There's a lot of concern that if they take on big projects, they're going to run their credit gets downgraded, right? Credit downgraded, you pay higher interest rate when you have to reissue debt, therefore your costs go up, right? It's a vicious cycle when you get into debt downgrades. So that's a big concern, and they're also worried about protecting ratepayers, right? We had Vogtle was expensive, right? Ultimately, if the liftoff report goes through and calculates what Vogtle cost, right, and talks about the cost reductions they got from 3 to 4.
You're talking about Vogtle nuclear plant in Georgia? Correct.
Yeah, when they finished Unit 3 and they talked about how much less Unit 4 was, right? And there was a significant cost reduction that Southern companies saw from 3 to 4, right? Just in learnings from, a lot of startup, a lot of learnings from what you did on Unit 3. And then, you get into what a Vogtle 5 might cost, right? If you were going to build another one, right? And that's kind of those.
When they build another one.
When someone builds another one. We'll see who builds that one, right? And then kind of what that capital cost would be, right? What we talk about, the overnight capital cost. That's if you instantly built it and just like that, at the flip of a wand, it was instantly built. That's the total capital cost, not including financing. But that's the biggest thing, right? Is you have to figure out what engine you're going to bring, how do you manage the risk, right? They're trying to manage risk. That's what utilities are basically doing, and that's what is holding everyone back, because no one, I would say, they don't really necessarily see the light at the end of the tunnel for how they manage all the risk and get to where they want in their risk posture.
Do you see, I don't know if it's in that report, but you could see whether it's a data center operator or a big steel company or whatever, I don't want to put words in Dr. Sadoway's mouth, but so if he didn't say this is on me, but he was talking about carbon-free steel or aluminum. He's a professor out of MIT. He's got a really cool TED Talk where he talks about no such thing at the time of the TED Talk as green energy without energy storage, grid level energy storage. And then he talked about that energy storage has to be local source. Doesn't do you any good to try to go through renewable intermittent energy that's pursuing sustainability goals if you're trucking it from across the country, or even worse, outside of your country. So it's got to be locally sourced. It's got to be very affordable, and it's got to be spectacularly safe. Those things for storage, so that you have this, that would be the firm power. So I have this, I'm getting all this megawatts from the sun. I can put all the extra in the storage, not only to do the ride through when the sun's not there, but some amount of overlap in case I have a cloudier day than expected or whatever. And he said, that doesn't exist. So it's not that these aren't great energy sources. They are, but until we have that, we need to call it something else because of the base load challenges. We talked a little bit about this. But he talked about if you used electricity to make aluminum, it's perfect aluminum, like whatever that chemical compound is, free of carbon, etc. And so I don't know if he said it or if I'm just thinking about it. So if you could put an SMR connected to that nuclear or that aluminum plant smelter, so I've got carb free, a small amount of waste here. We just had James Walker, who's CEO of, I think it's Nano Nuclear, on the podcast a week or two ago. And he wasn't talking about this, and he's in microreactors, not even SMRs. But he talks about these possibilities. And so for me, it seems when we were talking about where'd the investment come from, if it's not, and I don't want to presume upon a public utility, something that's outside their mandate or doesn't work well, but you could see where a private organization, whether it's a data center organization or one of these smelters, would say, well, can we, if not do it ourselves, because I don't know what that complexity is, but could we go hire TED's nuclear plant services? They come and they build an SMR or a microreactor or whatever. If not for us, for me and my frenemies, you were just talking about how we like to herd, and they put it there at the end of the cul-de-sac. My transmission is just a couple miles away in this community. Like, that's why I think they've got so much attraction to that.
Yeah, I mean, there's no reason you can't. And I think some of these business models are being figured out, right? I mean, we've now seen the big hyperscalers come out in some of their announcements recently, right? And Microsoft decided to reinvest in,
3 Mile Island,
TMI, right? TMI restart. Right. You have Amazon, hooking up with X Energy, and now, just last week they talked about they're actually working on some of the feasibility study in the Northwest there with Energy Northwest, right? And actually they're putting dollars up to go help fund that feasibility study, right? And then you have Kairos and Google talking about what they're going to start doing. So these things are starting now. What those agreements look like, I don't, we don't know, but I mean, people are starting to figure this out, I think. Yeah.
So, but that's not everybody that needs to be in the party.
Okay. I'm all for a big party.
Okay. Because at the end of the day, I don't think tech companies want to own and operate nuclear power plants. Mm-hmm. I don't think they want to operate energy assets. Personal opinion, mm-hmm. Maybe not well informed. Mm-hmm. However, there are states, for example, New York, Micron is building a massive chip manufacturing facility in New York, billions of dollars of investment. They don't have enough energy, right? So New York is like, we want to build nuclear, but for our utility, it's a balance sheet risk. We have an off-taker, right? What they're trying to do is figure out how, if I want to build an SMR and one hasn't been built before, and I want to be a first mover, how do I partner with people that want to be second, third, fourth, and fifth, maybe six, and we buy a pack of them. We decide on the same technology, and we build it again and again and again, and maybe it's in different states, right? Then you're leveraging different state incentive programs, right? Each state has different needs. That's the kinds of consortiums that I think we're going to see come together. We've had consortiums to balance the amount of generation that we've built in the past. There was it's actually still active today in the Northwest Power Council. The Tennessee Valley Corridor is another place where they've balanced the amount of generation that they've put out there. But you've got to get all the right people around the table. So if the tech company has the cash and the need and can write a PPA that says, we are going to buy this energy and we will help get it built because that's what we need, and it doesn't transition to the ratepayer, then your utility commission and your state is like, okay, we're good with that. Do we have, as a state, do we have a workforce? Are there other off-takers I can attract, right? And then it's working out, when do you need it, right? But when you build them, just like we were talking about Vogtle, right? When you build it time and time again, the projects get less riskier. The financing becomes easier. So these consortiums are about coming together and spreading that risk across a batch of plants.
Yeah. Well, I know our focus today has primarily been about nuclear power. In my conversation, and we've talked to a lot of the natural gas people, they talk about bridging. What I love by talking to a wide range of, I've yet to talk to solar people. I'm really looking forward to that. Because they've told me, sort of in passing, look, we actually have a great story. It's not being represented well. I would love for them to come and tell it. So, because I think these are, some of the things that we've talked about with respect to baseload and other things are legit. And so I'd love to hear more. But what people don't talk about regularly is they'll talk about, this is how we solve a problem, but they don't talk about, well, if you were to bridge, for example, natural gas, my friends at Natural Gas, and I love this idea, we'll be a bridging. Except here's the thing, you've invested, like I want to get every penny out of that infrastructure. And if I've invested all of this money into that infrastructure, it's less, and I'm not saying it's wrong. Again, I'm not, I'm not an expert in this area, but if we've got an excess of any type of fuel, let's keep working at how do we figure out how we use it or whatever. But that's what's a curious thing. And some of my former natural gas folks have actually brought this up to me. Yeah, what they won't tell you, though, is this. And it's not necessarily, it's a bad thing, but back to our conversation about full transparency, what is the total cost of ownership? This is what it takes in some places to build out that whole infrastructure. And now once you have it, and carbon capture is still evolving. I'm not in the, my carbon capture friends will yell at me. No, it's not. That's what I've been told. It's still evolving. So whatever it is that it may be that you've invested so much money into that, you don't want to invest into something to just pull out that plumbing and put something else in. And so that's why I like this conversation.
Well, I think it's about can a utility that typically has been in our country, the people that build generation assets, can a utility raise that large capital investment twice in a 20-year span? Because that's what you're asking them to do when you bridge with natural gas. Yeah. And that may be too big of a bite. Mm-hmm. I could totally get that. Chris already talked about the way they work their debt. So I think you have to come into these consortium conversations not only with, we've talked about this before, divorce the technology, come in being very technology agnostic and decide what are the factors that are most important to you, and let it play out. I think one of the factors we have to have in all of these discussions is diversity. Every technology has its pros and cons. We should be building systems that balance that. And where I've seen it do the most damage is to these small towns that I work with, these small communities that have been built around coal stations. Small communities have been built around nuclear stations, right? And when that becomes uneconomical, and natural gas, while it's been the cheapest fuel for a long time now in the recent history, if you look 15 years ago, 20 years ago, 25 years ago, natural gas prices would bounce all around. And so there was so you have to also think about the negative consequences of being too over invested. I wouldn't want people to be only a nuclear town. We need to be building diverse systems. Sure. It's kind of like sending your teenager out the door, right? Keep your options open, right? Yeah. Make good choices.
Yeah. Ish.
Right? But
diversify your investment account.
Yeah. I mean, this is it. So I think if we focus on the performance that we're after, and also nailing down a couple of things that have crippled us in this system. We're operating an energy system that was built by the generation before us. We have the opportunity.
What did they know?
Evidently,
Boomers.
They knew a fair amount because they're still working.
I know.
But we're building the energy system for the next generation. Yeah. And they're going to face challenges that we don't see today. Right. So building a resilient, diverse system, in my opinion, should be our priority, not the cheapest thing we can build today.
Right. I completely agree. With that in mind, I'm keeping an eye on the time. We've got just a few minutes left. We were talking about Vogtle earlier. I actually got to tour that facility recently. It was awesome and terrifying at the same time. Because when I pulled up to the gate on the outskirts of it, do you know how many security forces met me there and how many gates I had to go through to get on this thing?
Yeah,
I
we've
can
done
imagine.
it.
None. There was nobody manning the gate.
Oh.
Zero. No, but there's the perimeter fence. But all the things that I saw from the 70s and 80s and 90s, I don't know if this is a post-COVID thing or whatever, it's public knowledge. You just drive through and you get all the way up to and I think, of course, the nuclear stuff is the big towers, and that's just water and humidity and whatever, right? And so we actually got to not see the reactors, but see, I guess, the cap of the concrete that the reactors are underneath. And as they explain it, they're like, yeah, one, we have technology from, all the acreage that surrounds this thing. We know long before anybody gets here that somebody's coming here. They have fast reaction forces there on site. They've just evolved on, and they're probably, he said, it doesn't, before it looked more secure, it probably wasn't. Now it's exponentially more secure. And they have these pillboxes with people in them. And he's like, please don't press towards the nuclear reactor. It'll be a bad day for everybody, but starting with you. Then there's paperwork, and I started cracking up. But I thought there would be an army of people 2 miles away, and there isn't. They've changed how they do security. So
that's not necessarily a change.
Well,
they're depending on the plant, they're a little bit different, right? And they all have their own.
I'm just saying my physical, like in this reaction, it was, they walked through the security and it was pretty spectacular, but it just wasn't as obvious. It wasn't a big gate.
No, it's not as obvious as it used to be. And in some cases, it's very obvious so that you don't do stupid things.
I'm sure.
Yeah, and I think sometimes it depends on how close the parking lot is and where they put the, some of the barriers up around.
Well, you had to drive like miles from the edge to the thing. But this is what I'm getting at. We're talking about all of this. Do you think, in your opinions, there's going to be a lot of interest in the micro SMR route versus the big, I don't even know how many acres or miles that facility
Vogel
is.
is a large site, from what I recall.
Yeah, it was really, really big. And they had, their wind studies were counties, if not a state, involved, and all of these other things. And one of the things that seems attractive to us to mitigate risk is, again, not a micro or SMR expert, but as I've heard the conversation around them, it is you build these things in an assembly line on a factory, whatever that means to them. I'm not presuming I know. But they're repeatable, they're simpler in the way that these things go. And you can right size the size of them to whatever the location is. And depending upon how many nines, so if I need a 100 megawatt for the next 20 years, I probably wouldn't do 100 megawatt. I might do 350s because at some point, one of them is going to need to be serviced or refueled. And I've got to have my own ride through, and it's not going to be diesel gens while they're doing all of that. So do you think there will be quicker? Is there more interest in investing in micro and SMRs, whatever solutions finally make it through? Or is it still on the big plant?
I think it depends. Because it's all, if you truly need a large, because a lot of this, it depends on a number of factors, right? So when you go large, you have the economies of scale, like an AP1000, there's economies of scale. So if you talk about capital cost, right, your dollars per capital, because you're over a larger scale, you can actually get those numbers down maybe a little lower, right? Especially when it comes to earlier of a kind or earlier deployments, right? If you truly get really good at deploying, say, smaller reactors, and you can deploy them quickly, you can build them faster, you can, you do less construction time on site, maybe you can get those economics down a bit on the capital investment. But early on, right, people are still trying to figure out some of the economics for those. We know what the economics are for big reactors. We've seen it. And then some of the areas, right, you may not be able to put 1,000 or 1,100 megawatts on a grid in some places. You may be able to put 300 megawatts on a grid in places. You may only have a small grid that can only take, 10, 20 megawatts, right? So I think depending on where you want to be, there may be different use cases for what you're looking for. And then the other aspects in terms of you're talking about security, there's still things to be learned when it comes to, say, micro and what those look like with NRC regulations. Those are still being worked through, right? Some people are talking about mobile. Those are still being worked through. Those rules don't exist, right? The NRC doesn't have a thing say, hook it up to the back of the truck and you can go drive it down there and park it and turn it on. That doesn't exist yet. So those things still have to be worked out. So people have to follow along and see where they end up.
Navy ships, SMRs?
Yeah.
Mm-hmm.
Those are pretty mobile.
Yep.
We can
Yes,
take
they
them
are.
under polar ice caps. That seems.
We are
now,
not the DoD.
Do I want Bubba hold my bear and put it in the back of my F-250, which resembles me?
A little bigger than that.
I got my camo hat right outside. It's a true story. Well, here's why. I'm sorry. Go ahead, Christine.
Yeah, I think we're learning a lot about what energy demand really needs to be and what this rate of change really needs to be and how we're actually going to do that. I think that's going to be the conversation that dominates the next 24 months. And we will see some places emerge that say large light water reactors, large reactors are for us. You see a situation like Amazon and Energy Northwest saying, we know we need 3 now, but we're going to plan for 12, right? Because that's what we think that's where we'll be, right? And then but all of this really, again, it's all going to come down to how these different technologies shake out and perform. We've built an AP1000. We've built large reactors. We've built light water reactors. We need to start building some of these SMRs and test those theories. If we build it in a factory, we've said a lot of marketing. It's marketing right now. If we build it in a factory and I fuel it and it's small enough, I can put it on a truck and ship it. Is that economical? At the end of the day, the economics are going to have to make sense. and it's going to have to match the needs.
Do you think it won't be? Here's why my question. When we first built data centers back in the day, first of all, we converted brownfields. That's generally what we did. Get an old manufacturing plant, chip fab, an old Sears warehouse building or something, and they would build this infrastructure, what they call 200-year buildings. I mean, the concrete columns in these things, they could be nuclear fallout shelters. These are really impressive infrastructures. Even the old newspaper plants. We just don't make a lot of this infrastructure anymore, right?
Yeah.
So we repurpose it. We don't have to reaccount for all that carbon, like all these other things. Well, a lot of those places, if they're not gone, they are going to be gone. Everybody wants to reuse, and we should. But as we've moved into greenfield, what we'll do, let me finish that thought. And what we would do back then is, let's say I'm making a 50 megawatt building. I would deploy the entire 50 megawatt infrastructure. And I didn't have a lot of customers yet. So you want to talk about speculation and people getting anxious or whatever. And that was because you had to commission all the systems, everything at once. Well, 20 years later, we now know how to incrementally commission. We know how to add without disrupting production. We know how to demise the data. We've gotten very, very sophisticated, both our customers and ourselves. And they've also deregulated a lot of the risk, because before, the entire cloud was in that one building. Now it's part of an app for the cloud that's in that building, and the other part is 2 milliseconds away on the other side of town, and the other part's 8 milliseconds, or whatever it is, and they're tied together in an availability cluster so that if any one node goes down, so in other words, they don't have to have resiliency, they don't have to have any nines, really, ultimately, in any particular data center, because the data, this trifecta of data centers gives them that. So now when I build a 1 million square foot facility or a 500 megawatt facility, I am not commissioning 500 megawatts. I'm permitting, I'm doing all the groundwork, I'm basically urban planning the entire site around traffic and all of that stuff. And I'm building in the first few data halls. And then as we grow, we add more data halls and whatever, unless I'm going to use it all from day one. You know, if I'm launching a ship, an aircraft carrier, I'm doing the entire thing because I'm going to put it in service and I'm going to staff it. But in data centers, we don't have to do that anymore. It's very uncommon to do that. So that's I don't know what the economics are of an SMR or a micro, but for somebody like us in one of these iterations or other critical infrastructure, to be able to invest in something where I don't have to wait for the entire 2, 3, 4 reactors, 1,000 megawatt reactors to be deployed. And we've seen what it did to Westinghouse. We've seen what it's done to other companies. I can make something smaller and in the best use of their marketing material, just snap it together, because there's all these nuclear energy snappers out there to just click these things together. But this is the optimist in me. I don't know why I keep holding my chest. It's a little chilly out here in California. But this is like, can you see why this is so attractive to us? It feels like it kind of comes along with us just in time. It's a concept we can get our head around. Are we being overly optimistic?
No, I mean, I think there's a lot of people. I
don't think anybody knows right now.
I think there's a lot of people that want to get there, right? Do we know will it exactly work like that? I mean, you'd have to shoot. I mean, smaller modules in theory, you should be able to do that. That is the theory, right? And that is still to be proven whether they can work. Where you get like one module built and then you get the next module, still do the same construction, right? Because in theory, you'd not want interconnectedness between them, right? Relying on themselves, so you could put one online and then run to the other one. I think NewScale's module was somewhat like that. You build the big swimming pool and then bring modules in and commission them as you go, right? I mean, something like that is somewhat the idea.
I think generally, I mean, and the theories for SMRs and micros are different, right? So SMRs are medium-sized plants. You still have a secondary side, right? That secondary side is now going to be commercial grade, which is a little bit different than what we've had in our large light water reactors. But micros are, wholly, they're smaller, but you still have to have some form of a secondary side if you're making electricity. How small is that? What does it look like? There's different microreactor designs. At the end of the day, you're placing nuclear material somewhere. So you have to have an eye towards security. So what does that look like? Because I come from the operating with the commercial fleet before I joined the lab, I tend to always not necessarily think about what it's going to cost us to develop and build it, but what is it going to cost us to operate it as well. Right. And I think again, you have to look at that whole thing. Right. So if I have to have the nuclear, would you say energy snappers? I'm going to have to use that. The nuclear
snappers.
The nuclear,
like they're just out there.
The nuclear energy snappers to connect 10 micros together.
I don't know why they look like minions in my mind. That probably isn't a good thing, but I see them in their blue overalls and whatever.
I got my minion costume for Halloween.
I'm all about Dave and the minions.
But you have to think about so when you start connecting things together, you start to have dependencies, right? So you have to start thinking about what does that look like in an operating scenario? And is there, not saying that there is, but is there a domino effect if you have something that happens at one plant, but it does affect the other plant, right? And so while simplicity, right, it looks simple, right? Does it really seem like a good idea? Or should I maybe build something bigger that I grow into? Right. And I don't know what the right answer is.
Well, here's
I think
why
that's
it's so attractive to us, and we're trying to figure it out. First of all, unlike me, almost all of the people at a data center like mine are introverted engineers. And so they might have extrovert moments, but they are not extroverts. And so they're very all about calculation. And data center organization like ours, we're not all the same. We design them, we build them, we operate them, we maintain them. For the most sophisticated buyers, federal government, the most sensitive data on Earth probably is in one of our data centers somewhere. The big skiff rooms, all the things that you might imagine, very narrow list of who could go in some of those data centers. And so we spend a lot of time around operational maturity, resilience, discipline. I don't know what % of our operators are from either Navy nuke instructors, Navy nuke operators, military, we're SOP, MOP, EOP. So all of the lingo on the surface of we were bringing, when we're talking about the new power requirements of the AI stuff, before what would happen is this high voltage comes into a substation. Usually in my data center, we own it, or at least our side of it. We bring it down, we step it down into medium voltage, then we step it down again, and then we take it out onto the floor. Well, now we're considering, not just us, but everybody, do I make that DC so that I'm not having copper this big to run where a rack used to be 3.5 or 5 kW a rack? Now they're talking about hundreds of kWs a rack with all of the complicated water cooling inside those things. Again, we're, podcast conversations that we're having. And we know how to do those things. Like, we spend a lot of time. You're talking about dependencies. You should see how we route just fiber. Not only does it have to have multiple paths to our facility to various carrier hotels, but once it gets in the facility, it can't have any vertical crossovers. It can't come through the same conduits. Like, what's our fail-safe to the fail-safe to the fail-safe? Because if somebody touches that high voltage, safety is far and away our number. Everybody's got to go home tonight, hopefully with all the parts that they brought of them in, right? Much less our community and out. So when you talk about these very serious, consequential things, we lean in, tell us more. We're used to that kind of stuff. We're used to that sort of operation maturity. We deal with big finance dollars also, and we see a scarcity. We know you got to have connectivity. No, we're not in the fiber business, but we know you need to have connectivity and you got to have electricity. And for us to make it a data center, it's got to be always on. It's got to be powered. It's got to be always available. So it's got to be connected, and it has to always be secure. So if you go to depending upon which facility, you might go through the armed guards and multiple layers of security with blast doors. They're almost all, if not all, going to be heavily fenced and all these other things. And then once you get into the data center, there's concentric zones of security just to get to somebody's computer, because that's where the value is, right? We would argue that the ideas of the whole world live in there. So when we hear this level of conversation, where we get nervous is, what don't we know? Like, and by that I mean, why is this so attractive to us? Because we're not nuclear energy engineers or natural gas engineers.
I think the reason it's interesting, right, is the it's a similar culture and similar approach. And there's not many people that once you're in nuclear and you start to think and operate in this way, and I would imagine in data centers it's the same way, we encourage everyone across the board in these systems, from the admin at the front desk to the CEO. If you see a problem, if you have a concern, stop, ask the question, right? And I think it's that cultural match that can be the underpinning for making these decisions and working together to build the electricity that we need.
Yeah. I'll just say this last thing and then wrap up final thoughts. One of the things that we've learned, we talked a lot about energy and nuclear people, but anybody, especially at a company like ours, that has we find that with first responders or military people or whatever, they have a affection for the mission. They have an affection for the mission, and they have affection. You were just talking about this. It reminds me, we learned so much from the Navy in particular about know your job and know some of the job to the left of you and to the right of you, not so much to hold your brother or sister accountable, but to make sure you can spot they're not having a great day. There's like, for all of these reasons. So we're very community minded. That sounds crazy, but within our organization, and it spills outside of our organization. And Christine, you talked about on the other podcast and today, whatever energy source we're also talking about, and wherever new places we can go to, we also want to go to those, whether it's coal or whatever, traditional places that at some point are going to be decommissioned, even if they're temporarily running, because we've got to meet our energy goals. I mean, if we were very, very serious about meeting all sustainability, we just turn off all electricity now and we stop burning carbon, and then we can't do that. So we've got to have a path on the way to, we've got to eat on the way to paradise. So we really are attracted to people that not only want to bring that esprit de corps internally, but take it externally and find a way that the thing we're bringing into the community isn't just an economic benefit for us, but it's a community benefit. And how we do it, the seriousness with which we do it, it brings economic flourishing, it brings educational flourishing, all these other things. And so we're really interested, I think, those that take this seriously in that design, build, operate, and maintain world, if the market, without demonizing anybody, if it can't respond quick enough, how do we get engaged to learn more, either to facilitate it or to get involved in it directly? And you guys have opened the doors at INL, not just to us. We're just a couple of many participants that came up to start these conversations just in your own way.
I mean, well, there was, so we did have the INL kind of data center workshop back in early November, right? Or no, very late October, just before Halloween. And so, I mean, that's one thing to try to understand what some of the limitations are, right? And help get people involved, try to figure out what barriers we need to kind of knock down to help people understand how we can all work together and figure out how to plan to get there. Electric Power Research Institute's also kind of got some skin in the game working on that stuff as well. They have some R&D areas going on. But across these organizations, right? Like it's that's gonna be kind of trying to figure it out. But it's trying to figure out the first movers and trying to get things moving, and aligning the timelines, I think, is one of the important things. I think that's kind of the one of the themes that came out of our discussion in October is that everyone needs to move now. We want power now, right? But there's timelines to licensing, there's timelines to deployment, and getting those timelines kind of aligned and setting the expectations, I think, is important, because nuclear won't. You're not going to build one overnight. It just doesn't happen, right? Like, we have a few hurdles we have to jump through first before you can ever get there.
But depending upon who I talk to, Christine, I will hear somewhere between 4 or 5 years and 15 years. Like how, and some will say regulation, some will say not enough talent, whatever the reason is. What do you think is a real, if the liftoff thing was saying we should triple this, we need to get busy by 2050, like if presuming the finance is there, presuming the regulation, whatever that means, gets addressed, what do you think are real timelines for any of them, micro, SMR, traditional big deployment? Are we far
So
away?
we were actually
new?
talking about this morning in our staff meeting. It's really about how many applications for design are sitting with the NRC right now. I mean, and there's
Two.
There's two? I heard there's like 100.
Well, no. So now, there's a lot of people talking to the NRC, and what we call it pre-application engagement. People talking about designs. There's a lot of designs out there, and there's some people are talking to the NRC. But when it comes to actual license applications, right? There's actually two: TerraPower and the Kemmer, the station they're going to put the Advanced Reactor Demonstration Project they're building in Kemmer, Wyoming, right? That has a construction permit application with the NRC. We'll try not to go into too much NRC lingo. And then NewSkill still has their uprated design certification application in with the NRC.
And Kairos has gotten 2 construction permits approved.
And Abilene Christian University has the other one for a molten salt research reactor. So there's 3 construction permits the NRC has approved in the last 2 years? This year and last year, I think.
Yeah. So these developers have got to get their designs submitted. Now, one of the things we're also watching is what designs are being submitted in Canada, because our regulators are working with one another.
They're letting Canada do nuclear?
Oh, yeah. Canada's been doing...
I'm teasing.
From a grid scale, Canada's probably going to beat the U.S. to 1 on the grid.
Yeah. So to me, right, if you wanted to watch something, right, have they progressed the design far enough to submit it under application and ask for approval? That's, I think, that's probably the long lead item. However, there are things you can do ahead of that, right? You can do things that are technology agnostic. You can figure out your where. You can figure out your infrastructure. You can find a community that wants to have this. I would challenge tech companies to reconsider their decarbonization goals, and maybe pausing them or extending them and replacing them with energy justice. When we talk about not going to greenfield and you talk about using the brownfields that you had before, there was good reason to do that. If we go and build, I think the report says we need 700 gigawatts of firm power. If we do 700 gigawatts of firm power in this country from greenfield, now we have all these places that we're going to have retired stations, and then we've disturbed all of this other land and potentially devastated the communities that had those stations in the first place. So there's a lot of work with at the top levels of the DOE through the interagency working group to look at how we go look at our coal infrastructure first. We have retired and decommissioned nuclear sites that could be reused, right? So to me, I just think if we want what we want, and we want the pretty colors, and we want to have the stupid cat videos that put us to sleep or whatever, we need to not let one boardroom goal dictate how we do this. I think there are I think there's ways to get to a clean economy by 2050 at a different ramp that is kinder to the energy professionals that have given us power for decades.
It certainly has to be part of the conversation, right? My hope, one of the things that's exciting about talking about nuclear now, which I couldn't even imagined 5 years ago, maybe not even 3 years ago, but certainly not 5 years ago, is that now all of these are in, let's not demonize anybody, any particular energy source. Where do they fit? Where can they be used? What's the total cost of ownership? Where does it make sense? What workload do they solve for? Let's apply them wonderfully and let them go, and they'll continue to innovate and iterate in their space. But whether it's energy sovereignty for national defense reasons, or it is, the prosperity of our citizens, how do we make energy safe, affordable, local, always available, always affordable? We've got to be able to do those things, or we don't flourish. It's harder to flourish anyway. What haven't we talked about in this? I don't know. We've been all over my questions, so we got a few minutes left. What should we? How should we end it? What's the joyful, hopeful note that we should end on?
Well, I mean, I don't know. I mean, so the joyful, hopeful note is, I've been doing this here for about 3 years, right? And it first came into the role, and there wasn't a whole lot of discussion. There wasn't a whole lot of momentum, what you want to call it. But I've seen factors of improvement, right? And where things are being talked about now, where we're going is just there's a lot of things are being announced. Yes, they aren't true. I just say they aren't true.
They're the most optimist. That's what I find is that people are like in the most optimistic explanation of this.
They're not actual orders yet, but we're about as close to orders as we can get before you can actually have orders.
My
it feels
pipeline
like.
salespeople would say, "My funnel looks great."
Yeah. The funnel's there.
What paperwork have you signed? Right.
So I think the hopeful thing is, I think there's, and realize, right, there's a lot of stuff probably that we don't even see, that's the conversations that are happening, because there's energy runs through a lot of these public utility commissions, right? You don't get a public utility commission decision in 30 days, right? These things take a while. So if people are trying to work in areas with public utility commissions and trying to figure out how these deals might come into place, there's probably conversations that have been happening for months now that no one's even aware of, that are, hopefully we're going to hear about here in the next few months, which will lead to actual orders and actually gets to movement where we really want to go. So I'm hopeful that these things are happening and we're going to start to hear things. Maybe we'll have a happy new year on that moment here. Okay. Depending on when this gets published, by the way.
Well, now I have to publish it before the new year. Christine?
I think similar to Chris is the diversity of voices that have come to nuclear. We've been very much isolated, especially in the United States. After 3 Mile Island here in the U.S., we kind of put our head down and did our job, and flew under the radar. I meet people that are shocked when we tell them how many nuclear reactors operate in the United States and globally, and they're, that clearly that number can't be right. Do you want to play that game? We played that with national labs before. How many nuclear reactors operate in the United States, Dave?
I was prepared for the national lab conversation, which I think is 17.
Yes, 17. Good job. You remember that.
I remember. How many, is it 98? What is the number of nuclear reactor sites?
Well, there's units and then there's sites.
I don't know why the number 98 sticks in my brain. Is that the number of sites? It can't be that many sites.
No, it's not that many sites.
Okay. So if it's sites, it's got to be, what, 50? How many?
56, I think,
56.
is enough.
Okay.
And we are seeing activity in over 40 states exploring nuclear energy. And what is the most interesting to me is seeing people that are ready to talk about the whole ecosystem of nuclear energy and not just the reactor part. Because when I started with this and when Chris joined, that was one of the concerns I had, was that if you just hyper-focus on building new reactors, you don't have the supply system that, we want to make sure that everything's ready to go when we start to scale, right? And so you have to pursue all these things in parallel. So I'm excited about the diversity of voices in the conversation. I'd like to see nuclear people get out of their own bubble a little bit more and have conversations like this. We talk about things that none of us were experts on, but we wonder about, and that's how you solve these problems.
Yeah. So one of the milestones is, or canaries in the tunnel, is designs that actually get approved. So that, to see that, I had a weird, I don't know if it's a milestone, but a weird moment. So I have these daughters in their 20s. And around my house, I don't know why they are not lockstep with me about faith, politics, and cleanliness, but they are not. So I've failed as a parent. But a couple of them shocked me the other day. Literally, when they said something came up, I want to say it was talk about doing something with 3 Mile Island. And I had heard about it in one conversation away from my house, and a couple of people similar in age to me were like, oh, something's going to go wrong. What are they doing? They don't even know what they're talking about. And when I got home, my kids, it came up again. I don't remember how. They were like, oh, that's a great idea. That's interesting. And I was like, what? Do you even know what you're talking about? Oh yeah, Dad, nuclear energy. We all need nuclear energy. And they walk through these 2 legitimate college, educated people sitting there.
That you paid for.
That I paid for. Talking about, they had no fear. And I wouldn't say they were ignorant. They're like, nuclear power is safe. There's all these other things. I'm like, I got to go back out. Did I come into the wrong house? Because I just like that they're using their brain. I have people that are not big proponents of nuclear power, and they will give you their list of reasons. But I just like that there's this, at least at this generation level, they're in their 20s, but I would say probably 35 and under, certainly 30 and under. I don't detect a lot of fear when we're talking about nuclear power. It's like, oh, this could be interesting. How does this help us? This could be beneficial or whatever. And they're not demonizing other sources of power. They're just, okay, this is cool. This seems to make sense to me. Let's move on. I don't know what the big deal is. Whereas that's a generational gap from people similar in age to me that were much less reluctant to investigate the details.
Well, understand. I mean, I can't tell you how many projects I've done with, I have a junior in high school, right? How many science projects he came home that were about climate change, right? And, that was, so they've grown up considering the impact of not decarbonizing appropriately, right? And so then you get them into college. I think what I've seen is they start to do the math, right? And they're like, wow, okay, if you just, and there's all sorts of fun little calculators out there. We even have one. There's all sorts of fun little calculators where you're like, okay, if I want to decarbonize by
Did you just point to Chris and call him a fun little calculator?
Well, he is some days, but no, I wasn't meaning to.
I might change my ringtone, Chris, to Chris is calling fun little calculator.
Well, his ringtone for me is the A-Team, just so you know.
I believe it.
My family always knows. But I think that's because they grew up with that. When you think of our generation and above, we grew up with the vestiges of the Manhattan Project, right? And we're still looking at the cleanup of those sites. And, the Oppenheimer movie did a great job telling that story and what the mission was. That was a different mission. But what people did was equate nuclear weapons with commercial nuclear power. And they're 2 totally different things. And I don't think we did a great job separating that. Right. And you think about people that went through, I went through tornado drills in eastern North Carolina, but you went through drills about if there was going to be a bomb. Right. So they grew up with a different dialogue, right?
Yeah. I actually had a cousin out recently visiting with us a family event a couple months ago, and I had to drive her out to the town, and we were chatting, telling her about what I do, right? And she's like, "Oh, well, don't they have a lot of like waste stuff out in Washington somewhere?" I was like, "Yeah, but it's all weapons waste, right? It's not the waste from the power reactors." She's like, "Oh, I didn't know that, right?" So there's a lot of this, it's like you just think waste and you think, "Oh, it's just power." It's like no, there's a legacy there that things were done to win the Manhattan Project, right? To win the war, and that was what was done. And there's still dealing with that, but people don't really draw the, they just link everything together typically.
And kind of the cool thing, right, is we're starting to see in and around our national labs and Manhattan sites, we're seeing the ability to repurpose that land towards commercial power and doing the demonstration projects that we want to do to build new nuclear. In France, 77% of their power comes from nuclear. They teach nuclear in elementary school.
Yep. And they're working on recycling. They've got these recycling projects going on. And James Walker was telling me as well, there's so much, with their nuclear waste, they're like, here's all the waste. It's right here and it's tiny. And then here's how we're iterating to recycle it. We're learning how to recycle it. And now we can draw potentially this waste could power this much more. And this is how we're thinking about it. This is what we want to do with it. When you're talking about other kinds of waste, where is it? Well, it's around here somewhere. And so I just want people to investigate the facts, right, about all of these things. Where does it fit? How does it work? But also our optimism in this was a cure-all, not necessarily, and it may take us longer. Long before, instead of just popping antibiotics every day, why don't you sleep better and eat better and exercise so that you're healthier? But we have talked, and we could talk a lot longer. Christine and Chris, thank you very much for coming on the show.
Thank you.
Thank you. It was great.
My pleasure. Hey, if you liked that conversation, hit the like button. If you loved it, hit the subscribe. We'll see you next time, everybody. Bye-bye.